I'm happy to share. Yeah, I'll jump just very quickly into part of the demo that I did at BitCon. And I was primarily talking about retrieval augmented generation and AI agents. So, for those who may be uninitiated, retrieval augmented generation is a way to essentially feed a large language model new data. So large language models, whenever you first work with them or try them out, they can seem like magic, right? Where it's almost a sense of wonder. Man, I remember the first time I tried ChatGPT, I was on there for 3 hours, just putting in different prompts and trying stuff because it just felt, even though with me having been in the tech field for 11, 12 years now, it still was one of those revolutionary pieces of tech that comes along ever so often. But even though it felt like magic, it's really just data. And the thing is, that even though these large language models are trained on an incredibly large corpus of data, they still don't know everything. You can still hit the edge of their knowledge, and that can lead to trouble, right? Because you have some models that will do something called hallucinate, which is meaning they will very confidently give you a wrong answer. And if you don't have the proper context, because a lot of times if we're asking questions about something, we're asking questions for a reason, right? Because we don't know the answer. But if you don't even know the context around it, it can give you a very confident wrong answer and you won't even know. You just assume it's right because we assume it knows a lot or almost everything. But retrieval augmented generation, what that allows you to do is actually feed the large language model or augment its generation ability with new information that it may not be trained on. And again, just in the interest of time, I'll keep it quick, so I'll only do part of the demo. As you can see from my shirt, WNBA, I'm a big basketball fan in general. So with the context of the demo, we're going to use basketball. So as you can see, this is a very short script. This is written in Python, and I'm using a couple external packages that I'll very quickly walk through, just these under 30 lines of code. So what we want to do here is we want to attempt to reach the edge of knowledge of a particular large language model. So in this case, we're going to be using Llama 3. So we install a few dependencies. We install, in this case, we're not using Llama anymore. So that one's, you can ignore that one. But we're using some stuff from LangChain. So LangChain is a library that allows you to interact with different large language models and interact with a common interface. So we have the string output parser, we have this chat template, and those are going to help us basically structure first the chat template, structure the prompt that we want to give to the large language model, and then the string parser helps us parse the output into a string that we can then print out. And then we have a .env file that we're going to load, then the native Python OS package, and then another model from LangChain, which is Chat Grok. So Grok is an online inference interface that actually hosts several large language models that you can interact with. So we are going to use a Grok. We have a Grok API key that we're going to set as a variable here that we're going to then use to authenticate to Grok. So with Grok, we then can choose which model we want to use. In this case, we want to use an open source model that was created by Meta called Llama 3. It's the 8 billion parameter model. And then we have the prompt template that we reference. So we can say, write a joke about this topic, write a poem about this topic or what have you. In this case, the topic is going to be what we enter in from the user input. In this case, we just say, teach me about this topic. I'll make this a little bigger to see if that helps. And let's run this. So in this case, again, basketball guy here, I'm going to say, who the all-time leading scorer in NBA history. Again, I'm a basketball stats nerd, given very topical, right, that I'm on the Stats on Stats podcast. So this looks right.
But it's not.
Hey, Kareem Abdul-Jabbar, who scored an incredible 38,387 points. This was true.
But now it's LeBron.
Exactly. This was true until around 2 years ago. So we have reached the edge of the knowledge, at least in this particular topic, of what this model knows about. Because this hasn't been true for almost 2 years. So we can even see it actually referenced LeBron James in this answer. It says 35,237 and counting. So this was actually had to be trained a while ago. Because obviously LeBron has surpassed the 38,387 mark. So we see this is quite old, at least in this particular, the answer they gave here. And the thing is, these models are non-deterministic, right? So I can even give that same exact prompt again. It may give me a different answer. It's formatted differently, but it still says Kareem Abdul-Jabbar. Not correct. But again, if you don't have the proper context around that, you wouldn't know because it's very confident in this answer, right? So this is where we can use retrieval augmented generation to try to provide new or up-to-date information to these large language models. So there's a couple of different approaches of being able to do that. One approach that I showed in the workshop that I won't get to here just for time's sake is using what's called a vector database, where essentially you can read in whether it's documents in whatever format, whether PDF, CSV, even taking HTML and structured in a certain way, and you turn it into what's called in vector embeddings. So essentially you feed it to an embedding function, and then it will take that text document and put it into these numerical embeddings in vector space. And what that allows you to do is basically do similarity searches. So basically storing those into a vector database, you give it a prompt, instead of the prompt going directly to the LLM, it hits the vector database first, and you can give it basically a K number, like a K nearest neighbors or something like that, to say, hey, give me the 5 most relevant semantically similar chunks from this vector database. Then you can feed those into the large language model and let it structure the output for you. So that's one way to approach it. We're actually going to approach it a little bit differently. So still a RAG process, but we're actually going to use agents to do it. So let's clear this. So AI agents, you can think about as almost like autonomous little pieces, autonomous little workers that can then collaborate to accomplish a larger task. In this case, we're using a tool called Crew AI, and it's a really clean interface for allowing you to build AI agents. And excuse me, one of the cool things is that you can, for each agent, it doesn't have to be backed by the same large language model. So then you can start to do things, it's like a technique called mixture of agents, where you can start to have an agent that may use the Llama model that we're doing. You may have an agent that may use Claude's Anthropic model. You may have an agent that uses the OpenAI model. So basically you can now build these agents with different types of expertise, with different type of data that they've been trained on, and have them to collaborate to get, it's almost like coming together with people with different, like actual people with different expertise and different viewpoints, and then them collaborating to attack a common goal. Well, in this case, we see we have the Crew AI, we import that. Then we'll briefly look at this agents and task file that we define both the agents and the task. So if we look at the agents file, again, I know I'm blowing through this pretty quickly, but we define two different agents here with specific roles. We have an MBA researcher agent, and we give it a role, a goal, and a backstory. And we also say which LLM we want it to be backed by. In this case, we're also using that Llama 8 billion model, 8 billion parameter model. But one of the interesting things here is where the RAG part comes in, is that we can also give it a tool to use. In this case, this tool can actually go out and search the internet for new information for us. This tool is basically using an NBA API package that you can just download from PIP or whatever. It's a Python package. It's basically a wrapper of the NBA Stats API. And we can now use this to actually go out and search the NBA Stats API and give us back information. So again, I won't go through every line of code, but just understand this basically will say and again, we can say the top whatever, and it'll get the all-time leaders in a specific NBA statistical category. So the second agent we have is a writer agent. And what that does is that you can basically feed it that statistical data that we fetch from the researcher, and then it'll actually write out a interesting blurb about those particular stats. So it won't it not only would it just give you back the stats like in raw data, it'll then basically editorialize about them. Then we can quickly look at the task. So we have 2 tasks here. So we basically write 1 task per agent. So in this case, we say get the all-time leaders. So this is a task. It looks fairly similar if you've done anything with prompting before, where it says that analyze the user prompt and first determine which statistical category they're interested in, and essentially go and fetch the data for that statistical category. And we have an expected output, and then we can pass what agent is expected to complete this task. And just the same, we have a all-time, basically write a summary. So again, we want to pass in that data that we got from the previous task, and we want to write a clear and concise summary of the all-time leaders of a specified statistical category. If we think back to what the previous example, we saw that we wanted to ask who was the all-time leading scorer, and it told us Kareem Abdul-Jabbar, which is an outdated answer. If we jump back into the main file, we set up the researcher and the stats writer, we set up the two tasks, and then we assemble the crew. We have the agents here, we have the task, and then we can actually kick off the crew in our main function. So if we run this really quickly, so we can actually now see the crew quote unquote think, because I turned on the verbose flag. So we can say, hey, I need to determine which statistical category are they interested in. In this case, I said all-time leading scorer or whatever. So they then was able to infer, oh, that means points, right? So then it was able to go and basically just fetch the raw data. You see it again, thinking. I think I know the final answer. So now we have a structured output of the data, and then we see that chain is finished, and we're passing it to the writer, and we get this human readable summary where the all-time leading scorers are who's who a basketball legend. At the top of the list is LeBron James, who has dominated the league for nearly 2 decades and scored an astonishing 40,607 points. Cool. If we go to Basketball Reference, and obviously the season just started. I think they played last night, if I remember. I think the Lakers played last night. We can see this is actually up to date, like as of right now.
That's cool. That's hot fire.
So yeah, that's a.
Can you ask it if the Hornets are going to make it to the playoffs?
Ooh, it's one of those things. Do you want to tell the truth or
hallucinate?
Hallucinate for me.
Yeah, LaMelo's balling right now, but that's a tall task. The boy's cooking right now. He's out there just shooting one-legged threes and whatnot. But ooh, that's it could happen.
We already know the answer.
I know that. I love that definition of hallucination. It tells you to answer the wrong answer with confidence. I know a lot of people that hallucinate a lot.
Yeah.